Hello everyone, welcome to Geeks for Geeks. So today we are going to do problem of the day. The problem name is deletion and reverse in circular linked list. Now the problem statement is saying that given a circular linked list, the task is to delete the given node key in the circular linked list and reverse the circular linked list. So first of all, I hope you understood what circular linked list means. Look, a singly linked list, if I show you example of singly linked list, it looks like this, right? So this is a simple singly linked list, which is 1, 2, 3, 4, and 4 is pointing to null. Now, when we say circular linked list, it means that 4 is not pointing to null. It means the last node of the linked list is not pointing to null, but it is pointing to the first node itself, right? So this is circular linked list. So I hope you understood what circular linked list is. Now, what this problem statement is saying to us? It is saying that we need to delete the given node. The key is also given with the question, right? So we need to delete that key and then we need to reverse the linked list. So if you see, we are given with the combination of two questions. So the first question is delete a node from the linked list, and the second question is to reverse the given linked list, right? So this is a combination of two questions. So I think it is one of the best questions you will get. So let's try to understand the approach. First, we will see the test case, then we will see the approach to solve this question, and then we will see the code. Okay. After that, we will discuss the time and space complexity for this question. So let's understand the test case first. So if you see the first test case we have, it is like 2, 5, 7, 8, and 10, right? Now 10 is pointing to 2. As I said, this is circular linked list, right? Now what is going to be our output? So first of all, we are given with input and key, right? So key is not written here. Let me write it. So key is 8 in this case. Okay. So what we need to do, we need to remove this 8 node from the linked list. Once it is removed, our linked list would look like this, where 10 is pointing to 2. But we don't have to return it like that. Now we need to reverse the linked list. So after reversal, your linked list should look like this, right? So this is going to be your output, 10, 7, 5, 2. You can see the linked list has been reversed. I hope you understood this test case, but let's see another test case we have. So in the second test case, we are given with 1, 7, 8, and 10. So there are 4 nodes in the linked list. Now if you see, 10 is pointing to 1, right? And what we need to do again here also, we are given with a key. Let's say key is equal to 8. Now this key and the linked list will be given in the problem input itself, right? So we need to remove 8 again, right? So after deletion of 8, our linked list will look like this. Now after reversing the linked list, this output will look like this. So 10, 7, 1 will be our final output. So I hope you understood the question. Now let's see the approach for solving this question. So before talking about the approach, let me tell you a few things. There are lots of edge cases that we need to handle in this question, which maybe you are not able to think about them, but there are a lot of test cases or edge cases, if I say, are here that we need to handle. So we will discuss about each of the test cases. If you understood this approach that I have written here, then you will be able to write code very easily, right? So let's understand what are the edge cases we have while solving this question. So the first edge case, very first edge case is, what if list is empty of itself? Okay, so what do I mean? Let's say we are given with a linked list, and that linked list, how do you understand what you are given with in the linked list? You are given with head only, right? So let me take one example. So if this is your linked list, so each node has some address, right? Each node, like this node is stored at some address. This node is also stored at some address, right? So each of the nodes of the linked list is in some address. We don't know those addresses, but we don't even want to know, right? So we are given with a head, which is the starting point. It stores the address of the first node of linked list. It means if I have this head, it means I have the address of this node 1. Since 1 is connected to 2 and 2 is connected to 3 and then 3 is connected to 4, right? It means if I have this information of head, then I can not only get the address of 1, but from that 1, I can get all the node addresses, right? So this head is very important for us. But think of one case, as I said, what if your list is empty itself? So let's say if your head is pointing to null. If your head is pointing to null, it means that it is not pointing to or it is not storing any node address. So from that, can we say that linked list is not there, right? Or linked list doesn't exist. So in that case, there is no point to talk about the deletion, or there is no point to talk about reversing the linked list, because linked list is not there, right? So this is the first case, very first case that we need to handle. Now let's talk about one more case we have. So what if key is not present? What do I mean to say? Let's say we have a linked list, right? 1, 2, 3, and 4. Now, since it is a circular linked list, so 4 is pointing to 1. But we are given with a key that this is the key which we want to delete here. But if you see, if you traverse in the given linked list, we don't see any node with data 7. It means the key is not present. In that case, what you need to do? You need to return the original linked list itself. And then you need to reverse the linked list as asked in the question, right? So this could be your second case. Now let's see some more delete scenarios we have, right? So these are the first two cases that we have discussed. In this, if you see, we are not deleting anything, right? But now let's talk about when we have to delete. Now, while deleting, we will again have some cases, right? So let's discuss them as well. Okay. So the very first case I can say is, let's say you have only one node in the linked list. So what do I mean? I mean, I have taken one example here, right? If let's say we have only one node 5, and 5 next is storing the address of itself. So in that case, we have to, or if suppose this linked list is 5 and we are given with key 5, right? It means one node is given and we need to delete that node itself. So what do you think? What we are left with? So after deleting, we are left with no node in the linked list. So in that case, what we need to do? We have to return the null or none in Python, because we don't have any node left in our linked list. Okay. So this could be the first case. Now, the second case we have is, let's say this time we have proper linked list, that is 4, 6, 8, 9, 11, and 11 is pointing to 4. So we have a circular linked list here. Now key given is 4, as I have marked it as red. It means we have to delete this 4. Now how you are going to delete this 4 node? That's very simple, right? We can delete it. Like, we will discuss the approach for that, but we can delete it simply. But after deleting, do you see any problem in this? Yes. If you see 11, the last node of the linked list is pointing to 4. Now, if we delete this node, it means now 11 is not pointing to any node. Now this will be not a circular linked list anymore. But we don't want this, right? We don't want our circular linked list to break. So what we should do? In that case, what do you think? What should be the approach? In that case, what we can do, we can say, okay, this node is going to delete. But after deletion of this node, what do you think? Which is going to be our head node? Because right now our head node is storing or pointing node 4, right? Because this is the what I said. Head is going to point to the first node of the linked list. Now since 4 is the first node of the linked list, so head is pointing to 4. But if I delete this 4, as asked in the question, if we delete this 4, then what will happen with the head? Now head should point to the second element or second node of the linked list, and that would be new head. So head will start pointing to 6, right? But what about this 11? 11 is still looking for that old head node. That doesn't exist. So in that case, what we should do, we should say, okay, 11 should now point to whatever we have the previous node. It means before deleting this 4, we can say that 11 should point to 4 next, that is 6. So first of all, we need to update this link. And we have to say that 11 should now point to 6. And after changing this pointing, we need to delete this 4. And don't forget to update this head after that, because our new head will be 6, right? That is very crucial step. So I hope you understood this case as well. Now let's discuss the third case we have. Now we have talked about head in a lot of other cases. Now let's discuss when we don't have to delete the head node and we have to delete any other node, right? In that case, what do you think what we should do? Let's take an example. So if you see, we are given with 1, 5, 2, 6, and 9, right? Now, if I'm asking you to delete this 2 node, then it's very easy for us, right? We just have to delete this node. But the problem is 5 is pointing to 2 and 2 is pointing to 6. Now, if we will delete this, we will break the circular linked list. And now 5 is pointing to nothing. And also we will never get, or we will never reach to node 6. That we of course don't want. So what we should do here? we should make sure that before deleting 2, what we should do, we should say that 5 next should point to the node which 2 next is pointing to, right? It means this should point to 6. So if we modify this link after that, we can peacefully delete this 2 because it will have no impact in our existing linked list, right? And we don't have to change any other pointings here because this is not a node which is head, right? So we don't have to do anything else in this case. So I hope you understood all the deletion scenarios we have. So before starting the second function we have, like reversing a circular linked list, first let's discuss the code, whatever we have discussed till now. So let's see the code. So I have already written the code for delete node because since the code is a bit long and the video will be much longer because of this. So what exactly we are doing? So step by step, whatever we have discussed, the same thing we have implemented in our code. Let's try to see each of the line. Now, as I said, right, the first case, as I said, what if head is pointing to null? Let me show you that, right? What was our first case? I told you, right? Like if the list is empty, if the linked list is empty, how we can find our linked list is empty? If head is pointing to null, right? So in Python, it is none, not null. So if head is none, then what we should do, we should just return the head itself. It means we are returning none only. So this is the first case which we have discussed and we have handled. Now, if you see further, we have other cases as well, right? Now, if you see, I have written current is equal to head. So what exactly I'm doing? I'm creating a temporary variable in which I am pointing to the same node which head is pointing to, right? It means the first node of the linked list. And then for now, let's say previous is another variable which is pointing to none for now, okay? So what exactly we are doing? So if current data is equal to key. So right now, as I said, our current is pointing to head, right? So if head dot data is equal to key, it means the node we want to delete is the head node itself. And as I said, right, there would be two scenarios in that case. Let me show you. Like if we want to delete the node, right, and the node itself is head, then we have to check first if head dot next is equal to head. It means this is the case 1 that we have discussed. It means we have the only one node in the list. So in that case, if we have to delete that node after deletion, as I said, we have to remove, we have to return none only, right? Because we have only one node and that we are deleting. So we just need to return none. So that's why I have written head dot next is equal to next. Head dot next is equal to head. It means if head dot next is not pointing to any other node, but it is pointing to itself, it means there is only one node in the linked list. Okay. So this is one case that we need to handle. After that, what if we need to delete the node head, but it is not only one node in the linked list this time? Like as I taken in this example, if you remember, we had 4, right? We had 4 here. If you remember, this was the original linked list. So if you need to remove this 4, what exactly we decided to do? First, we need to go to the last node of the linked list, and then we have to change the link. Okay, so that's exactly what we are doing here. While current.next not is equal to head, it means while traversing, we don't reach the last node of the linked list. How we will find out that we are at the last node of the linked list? So if 11.next is equal to head, it means we have reached to the last node of the linked list. So that is what we are saying. If current.next is not equal to head, till that time we will keep traversing, right? And after we have reached to the last node of the linked list, we just need to delete we need to change the pointing, right? So as I said here, right? As I said here, that after we reached here, we need to point this 11 to 6. How we are going to point this 11 to 6? Right now we are here, right? This is our current node. So can we say current.next is equal to what? Head.next, right? Since head is pointing to 4, so head.next, it means we are talking about 6. It means 11 should point to 6. So we have broke this link and we made a new link here. Now after that, what do you think? What we should do here? After that, we should directly return the new head, right? Which is our new head. Now after deletion of this, our head should point to 6. So that is what we are returning, right? So we are returning current.next. Now let's talk about the third case we have seen, right? Let's discuss about the third case. It means deleting any other node. So if you remember, we have one node 2 here, right? And 5 was pointing to 2 and 2 was pointing to 6. So what we have decided, first reach to this 5 and 5 should point to the node that we want to delete dot next, right? So 5 should point to 6. So how we are going to do the same? So what we are saying, while current.next not equal to head. It means we have not reached to the head again, right? And current.data is not equal to key. And if current node data is not equal to the given key, till that time we will keep traversing. And after we came out from the while loop, it means either we have reached to the end of the linked list, or end of the linked list, I mean to say, either we have reached to the head again, or we found the data, we found the key, right? If in either of the case, what exactly we need to do? We need to say if current.data is equal to key, if this is the case, then we need to say previous.next is equal to current.next. It means, look, here exactly, this is our current node, right? And if this is the node that we want to delete, that what exactly we need to do? We have taken another variable here, which is previous, right? Previous, which is now pointing to 5. Now, if I have to delete this 2, what exactly we have decided that 5 should point to 6. And how we are going to achieve this? We are directly going to write the previous. It means 5.next. It means 5.next should now point to which node? It should not point to 6. So can we write current.next? Because current.next will have the address of the 6. So we are writing this line, and this line will just break this link, and 5 will start pointing to 6. It means we have deleted this node too, right? So we are done with this, and we will return the head of the linked list. That is the original head of the linked list, because we have not changed head of the linked list, right? So this is the code for the delete mode. I hope you understood. Now let's discuss about the reversing the linked list, right? Or reversing the circular linked list, to be very sure. If you have solved reverse a linked list question before, then reversing a circular linked list is very same, right? Except the last step where we have to retain the original linked list. Other than that, everything is same. So let's discuss about that. So first of all, here also we have some cases. What if list is empty or has only one node? In that case, we don't have to reverse anything, right? Because think about yourself. Like if you are the only person, right? If you are the only person in a queue, then how you're going to reverse that queue, right? Because you are the only person. Or if the queue is empty, in that case also, we don't have to do anything, right? So this is the edge case that we need to handle. Now, if you know how to reverse a linked list, we need 3 pointers for the same, right? We have other approaches as well using recursion, but this 3-pointer approach is very easy to understand and very easy to write while coding, right? Let's try to understand. So I have taken 3 variables here, that is previous, current, and next. Okay. Now we will be using, why I have taken 3 variables? So previous, this variable will keep track of the previous node. This current variable will keep track of the node that we are currently on, and the next will take care of the next node of the linked list. Okay. And then after that, we will reverse the link. Now, how we are going to achieve all of this? Let's try to see them in action. So I have taken one example to make you understand here. So let's say initially our linked list is 1, 2, 3, 4. As you can see, 4 is pointing to 1, right? So initially our current is pointing to 1, right? Our current is pointing to 1, and our previous is null. So previous is not pointing to any node because this is the very first node. So how can you say which node is the previous? No node is the previous, right? Because this is the first node. Okay. So right now, what we are exactly going to do, we are going to break this link. Why we are going to break this link? Because we need to reverse the linked list. So for reversing the linked list, we need to break this link and we need to point it to the null for now, right? So how we are going to achieve this? So if you break the link, then the problem is that let me show you just a minute. If I break this link, then I will not able to reach to 2. So we don't want to break the link directly. There is a rule in linked list, make before you break. So before breaking anything, make sure that you have taken that reference. So that is what we are doing. So before breaking this link, we are storing it, right? So I have taken another variable future, which is like next. I have named it some different because next is very similar to what we have decided. So it will be quite confusing, right? So there are 3 variables we have. One is current, one is previous, and one is future, right? So I have taken in place of next, right? So the future will pointing to the node which is just next to the current node, right? So the current node is 1. So the future node will start pointing to 2. So I'm denoting it by F, right? So now future is equal to current dot next. It means future will point to the next node of the current node. Okay. Now, since we have taken the reference, so now we can break this link, right? So let's break this link. So for that, what we are going to do, we are going to say that current.next should point to previous. So what is the previous we have? So we have decided that previous is nothing right now, right? So previous is pointing to null. It means our current node will start pointing to null, right? Now, after achieving all the things, now our linked list will look like this, right? But don't forget to update the pointer, because look, Now we are done for the one node, right? Now we need to traverse in the second node, but for traversing we cannot write current is equal to current dot next, because if we will write this, then current is 1, right? Let me show you. So right now current is 1. So if we will write current is equal to current dot next, then 1 will point to null itself. But we want to now do the same operation for the other node of the linked list. It means first we will do it for the 2. So make sure you are updating like this. So we need to write previous is equal to current. Sorry, I've written it incorrectly. It should be previous is equal to current. And current should point to future. It means now our linked list will look something like this. Now you can see, now this linked list is not circular anymore, right? Because we have broken this link. So our linked list is not circular. So that's the reason we have to make sure that we retain the circular linked list at last. Okay. But for now, we will be doing it in the last step. So this is our linked list. Now current is pointing to 2. Again, we will do the same thing. We need to reverse this link as well, right? So for that, first, don't forget to save, right? It means first we will say that 3 is the future of our linked list, right? So what we can say, we have stored it. Now we can break this link. So what we can say that now current should point to the previous node. It means, as you can see, now we are achieving what we want to, that 2 is now pointing to 1. It means 2 is now reverse. 2, 1 and 2, you can see is reversed now, right? So after that, we have written current dot next is equal to previous. It means now 2 is pointing to 1. Now next is, now we need to update this and we need to move to the next node. So for that, can we say that current should point to future, so that current starts pointing to node 3. And if current start pointing to 3, then we need to make sure that we are updating previous node as well, right? Now previous should point to 2, right? So that we need to make sure. So I have written the same. First, previous is now started pointing to 2, and now current is pointing to node 3. So that is what you need to do. I hope you understood what actually we are trying to do. And if you will do the same, then after case 3, your linked list will look like this. It means now 3 pointer has been reversed. Now 3 is pointing to previous and 4 is the current node we have, right? And for the 4, again, we are going to do the same operation. Now 4 will start pointing to 3, right? Previously 4 was pointing to 1, right? But now if you see, now 4 is pointing to 3. Now there is, as we have said, there is no circular linked list anymore. So now 4 is now pointing to previous. So are we done? Because the linked list is reversed, right? So we should stop now. Why we should stop? Because if you see, we have again, our current is again pointing to the head node, right? It means we have reached to the point from where we have started. So we should stop here now and we should terminate the process. Now once you terminated the process, now your final list will look something like this. This is the exactly same list that we have achieved here. Just I have written in this form now, right? It means 4 is pointing to 3. As you can see, 4 is pointing to 3, 3 is pointing to 2, 2 is pointing to 1. So that is what we have written here. 4 is pointing to 3, 3 is pointing to 2, 2 is pointing to 1. But now the problem is that we don't have this link, right? Because now 4 is pointing to 3. So we don't have any link. So we need to restore the original final circular linked list. So for that, we will say that how we can achieve this. So we want to achieve so that 1 should point to 4. And this is how we can achieve the circular linked list we have. So what we can do. So if you remember, 1 is what? 1 is head, right? So can we write 1 should point to the previous node. And if you see in the last step, previous is still pointing to 4, right? Previous is still pointing to 4. So can we say head dot next is equal to previous? Head dot next is equal to previous. I have written here, by the way. So if I am saying head dot next is equal to previous, then our circular link has been also restored, right? So this is going to be the whole approach to solve this question. Now let's see the code here. So if you see, we have done the same thing. If head is none or head dot next is equal to head, right? It means if there is no node in our linked list, or we have only one node in the linked list, then we don't have to do anything and we just have to return, right? No process involved here, right? Now, so we have previous is equal to none, current is equal to head, and init is equal to head, right? So this will work as the same, like that we have discussed, and we had future variable. Here we have init, right? Now, this loop will keep running till we don't break it, because it is a circular linked list and we have to manually break the link. We have to manually break this loop. Otherwise, it will keep running infinite times. So first of all, what exactly we are doing? First of all, as we decided, first we will save, right? So we are writing next node is equal to current dot next. It means before breaking the link, we are storing our current dot next address in the next node variable. Now after that, as we decided that current next should now point to the previous node. So that is what we are writing. After that, we are updating the third thing, right? So we are just following what we have discussed here. First save, then reverse link, and then update pointers, right? So in place of future, we have this next node, right? So let me write it so that you can recall what we have discussed. So the previous future is now pointing to current dot next, as we have written here, right? Current dot next should point to previous. It means we are reversing the link. So current dot next should point to previous, and then previous should point to the current. It means we are updating the links, right? So previous is pointing to current. Now after that, current should point to future, right? So let's, as we have renamed this, so current is pointing to future. So that's it. And how we can break from the linked list? Once we say that the current is the original head of our linked list, it means we have reached to the point from where we have started. And this is the point. If you see, this is the point, as we have discussed, we should now terminate when current is again pointing to 1, right? So that is what we are doing. And after that, we are writing this line. Why we are writing this line? Remember? Yes. So we are writing this line so that we can store the final circular linked list. That is head.next is equal to previous. So head.next is equal to previous here. And finally, we are returning previous. Why we are returning previous here? Because if you see, our final new head is 4 now, right? New head is 4 now. And where we have stored the address of 4, if you see in the last step, 4 address is stored in the previous variable. And that is the reason we are storing previous here, right? So let's now discuss the time and space complexity for this approach. Since we are just traversing in the linked list in both the delete node function and in the reverse node function, right? So we are just traversing the linked list once. So the time complexity is going to be the length of the linked list, which is big of n. Now talking about the space complexity, since you can see we have just created few variables. Other than that, we are not using any other thing, right? So these variables will not take space, right? It will take some constant of space. So the space complexity is also big of 1 only. So I hope you understood this question, and I hope you will be able to write the code by yourself. Thank you for watching this video.